You guys ready to listen to me talk for a bit? So I'm Isaac, and I'm going to be talking about simulation as art. First off, I just want to say thank you guys so much for waking up this early. I know it was difficult for me to get up, so I'm glad you guys are here. I want to keep it pretty casual. I'll do sort of a presentation, but please, I want to leave a lot of time for questions because I found that with this specific presentation, usually there's some weird questions that people ask, and those are really interesting to talk about. So please think of questions and then ask me at the end. You can also, if you have any other questions later, ask me on Twitter or ask me in person. So I basically want to start off with a kind of cliche question, but like, what is art? And for me, art really basically comes down to us as humans and it being used as a way to communicate. And so I sort of want to talk about, first off, what communication is. And if there's anything you should take from this, it's that you don't need to be able to draw to be able to do simulation as art. So this is a person and they have an idea, right? That's a light bulb. So they have this idea, it's in their head, and somehow they want to get that idea into the world or communicate it to somebody else. So in this first example, they like take that idea, somehow things happen, and it gets like pushed down through their face and then out of their mouth and bleh, goes out into the world. So this idea is now like floating out in the world as these sound waves, and it goes through space, and then there's another human being somewhere around there, and it's got these super powered idea receptors called ears, and that idea comes out of the mouth, floats out into space, and then hits the ears, and all of a sudden is inside that person's head. So this is really exciting to me because it kind of means there's one time when Kim Perlin said that like we are all superhumans, and like our superpower is the ability to communicate. Like we literally have the ability to do more or less telekinesis. Like we use airwaves to do it, but we can take something from inside our head and literally take it and put it inside somebody else's head. And that is like absolutely insane to think about. So for me, this is a lot of what art is. It's like trying to take something that you couldn't necessarily communicate via mouth waves and communicate it via some other media. So this is to say that sort of art and communication is a way to get to experience reality. And specifically, it's a way to get to experience reality together. So one person looking at a bunch of flowers is great, but as the saying goes, if a tree falls in the forest and there's nobody there to hear it, does it really fall? For me, the question is, if a tree falls in the forest and there aren't enough people there to sort of decide that the tree fell in the forest, did it actually happen? So just flowers and just one person seeing flowers is something beautiful, but when you have somebody else there to witness the same reality and together decide upon that reality, that to me is when it becomes really special. That's when it becomes going from being lonely, a single being, to having community and having connection. The cool part, though, is that part of this superhuman power is being able to have an idea. So in the first one, you saw the light bulb in the head, but there wasn't necessarily a light bulb in space. They actually took that thing from inside their head and they created something and brought it into the world. So let's say there's two people, they're looking at a circle, right? But one of those people says, oh, that isn't an outlined circle, that is a filled-in square. If both people are looking at the same reality, they can sort of say like, okay, no, it actually isn't. You're saying it's a filled-in square, but it actually is an outlined circle. But if you are hearing that in a way where you don't get to see the circle itself, that outlined circle actually becomes a filled-in square. It isn't as though it is a filled-in square. It literally becomes that because you have no ability to perceive it. So that's super, super exciting. Because that's what all movies do. They communicate something that is of one reality, take it out of that reality, put it into another reality, a theater or a home theater or whatever, and the person who is watching it actually gets to experience it in a way where they don't see the original reality, they only see the simulation of that reality. So this, to me, is really exciting because it sort of is how we, through the ages, have built connection. So, way back when people might paint, and then people who saw that painting would go like, oh, okay, here's this idea that you're manifesting of this reality that I might not be able to perceive, but now comes into existence through the paint strokes. Later on, it might have been a drum, and people got to listen to that and say, okay, I see that you are creating some sort of reality, and even though it is not my reality, I'm now able to experience a new reality, and that's quite exciting. And now, that's supposed to be a Vive controller. We can manifest all these other weird new things that we can't even begin to explain or think about. So that's really cool, and in all those examples, sort of like the original like cave painting or more specifically maybe music, the problem with it is that you actually had to be in the same room as the person who was playing the music. So if you think about like old orchestras, like you could never hear a recording of an orchestra. You actually had to be at the orchestra to hear what the orchestra was playing. What's amazing for us, especially with computers, is the ability to have memory, for a reality that we manifest to actually be contained within a chip or whatever else, and that can exist for longer than the creation of that reality actually, longer than the creation of the reality. So somebody, they come up with this idea, it flows out of their brain in whatever medium they choose. In this case, I'm going to use VR as an example. So they go and they code and they do all the crazy stuff, and then that flows out into the world, and then it goes into a computer chip, and that is supposed to be a computer chip. And all of a sudden, like all of that reality, all of that crazy thought that that person had that came out of their mind is now like contained in this tiny little thing. And that's super exciting because it means that when it blossoms forth and retells that reality, it can go to so many more people. So this is one of the most exciting parts about VR and about malleable reality is the fact that like that tiny computer chip then can communicate that data so millions of people over the world can be experiencing this reality that they could not before. We get to sit, and when somebody sees something beautiful, some gem within their mind, we get to watch that be manifested in the world, and we get to experience that beautiful reality that they want to share with us. We get to communicate and make that reality real. So that sort of is like the basic weird philosophy part of the section of this presentation. And now I sort of want to talk about, for me, what is so special about computation. So I forget who exactly, I think it was Brett Victor was talking about how with computers, it's amazing because we have these devices that can do so much, but typically when people are using computers, they're using it to consume media that you don't actually need computers to consume. So it's either like you're reading blog posts, you're looking at images, you're on Facebook, or you're watching a movie. And all of those don't actually require a computer. They require a way to be able to play back images or display text, but you don't need something that is capable of computation. Yeah. That being said, we have these computers, like what can we use them for? What stories can we tell? What sort of ideas can we begin to communicate from our mind that we weren't able to communicate before? What sort of realities are we able to talk about that we aren't able to talk about before? And one example that I always really like to show is this demo by RGBA. And I'm assuming here it's less necessary to talk about what the demo scene is, but real quick, this is a 4K demo, so not 4K resolution, but 4 kilobytes. So all of this was made in 4 kilobytes. And I went a few Siggraphs ago to hear Inigo give a talk about it, and he said about 3 kilobytes of it was all dedicated to creating the audio. So all of the visuals you're going to see in this are made in 1 kilobyte of data. And we'll watch this for a little bit. that obviously it goes on for a while, but that sort of is a really delightful demonstration to me of what computation is capable of. So even though we saw a recording of that then in a YouTube video, that object itself is running in real time, which means that it can be reactive. And that to me is sort of the core principle of what I'm interested in exploring with computation in general, is the concept of reactivity. So basically every single medium that we've looked at before has been more or less static. And so, you know, when you watch a film, you're going to watch it, it's going to be the same every time. When you read a book, you're going to read it, and it's going to be the same every time. You might get to bring your own emotions to that, and you might get to sort of change the way that you interact with it, but the media itself remains static. That is not necessarily true of dynamic media. So for me, the concept of simulation and the concept of real time is really, really exciting. And what I'm talking about here is not necessarily just real-time rendering. In Elevated, it's a really good demonstration of real-time rendering. But the problem is that even with Elevated, it's going to be the same every time. When you think about something, when somebody bakes an animation, that animation is going to be the same every time. When you see a walk cycle, even though you might be walking in different directions, the walk cycle itself is going to be the same every time. There is some dynamic input, but with something like VR, with something like AR, where we get to be interacting with it in a more humane way, the world needs to be as reactive as the input system. So when I'm using a mouse and keyboard, it doesn't matter that something doesn't feel that viscerally reactive, but if I'm going to touch the hairs on the back of a polar bear in VR, if it doesn't react exactly to my emotions, that breaks the sort of immersion of that reality. So that basically is what I've been focusing on. And I sort of want to show you guys the first experiment that I did in VR with Unity. So it wasn't supposed to look like this. It was supposed to be a donut shape. But basically, as soon as I got this working, I was just like, oh my God, this is so much fun. And I ended up just playing with this for a really, really long time. So it's not animated. It's actually simulated. And what that means is that however I choose to play with it, it interacts with me in a way that like I get to make it my reality. It no longer is the reality of the creator, it's the reality of the person who is interacting with the object. That soon became this, which was, you can see that I sat and played with it. I'm going to turn the music off because it makes it look stupid how much I'm dancing with it. But basically, I'd make this donut, and then I put on music, and then I just play around with it. And one thing that I've basically used as a litmus test, especially when I'm developing for VR, is basically if it becomes so hard to work on an object because you're too busy playing with it, that's probably a good sign. And it probably means that you should keep on going in that direction, even though it means that programming is much more boring. So you can see that this becomes sort of its own reality that you get to discover and explore. When we interact with reality, the way that we learn about it is basically by this data input and output mechanism. So we do something to the reality, we get data of sort of how that input affected the reality, and it comes into our mind, and then we say, okay, now I understand a bit more about how this reality reacts to my emotions, reacts to the way that I interact with it. And so basically, the more that that thing can react in time, in like human scale, real time, the more quickly I can begin to understand what exactly that reality is. I'm going to pause this because it is definitely very bright and distracting. So basically, like, it means that all you have to do is make the simplest of realities. A simulation is nothing but the simplest of realities. That weird rainbow donut is nothing but a very, very simple reality. But the act of getting to explore and understand a reality is one of the most compelling things that we can do as people. To me, that sort of is like the basis of learning. It's getting to play with something that I do not yet understand. And as it reacts to me, as I engage with it and begin to understand its movements and the way that it is formed and the way that it exists in this world, I get to like learn more about the world itself. And that's super, super exciting. So this later one is me trying to figure out how to program hair, and then having basically not just an object that I can play with, but then some parameters that I can use to control that object. So in a little bit here, I will, you'll see me grab the interface and then actually change that. So it's not just a reality, but it sort of is like a possibility space of possible realities. So they can be short hairs, they can be long hairs, they can be pushed away really far, they can be pushed away very low, they can have high dampening, they can have low dampening. And all I do now is explore this reality. So basically I'm showing you that because all of these three things were some of the first three experiments that I did in VR using Unity. And this was 2 years ago. So fast forward, 1.5 years ago. So fast forward 1.5 years, and I started doing the Unity Artist in Residence program. And it's amazing because for me, and a lot of this is because I'm just not that good at programming or math, I'm still sort of exploring those same ideas. There is so much within just like a gooey texture, and there's so much just within hair that I really think that like you could explore those specific simulations and be able to see what different things that they do for your entire life. So I started making this weird little audio reactive thing for one of my friends. We'll watch it for a bit. If it loads. And this was I really wanted to make it so I could learn about the post-processing stack, so that's where there's a lot of glow. I think that's actually probably enough of this one. So basically with this, I had learned how to make a GUI object, and then I was like, okay, well, what if I put GUI hair on top of that GUI object? So it still is exploring a simulation and then layering simulation on top of simulation and really trying to understand the possibility space of those simulations. So I made that object, but then obviously the next thing to do then is to bring it into VR and see what it's like to actually touch that. And what's really cool about this is that basically I've been wanting, so I'd made all these simulations, and a lot of them reacted to audio, but they never created audio. And that was simply because I'm doing everything in compute shaders, and I didn't understand compute shaders enough to be able to do something with it. So the first day that I was at Unity, I was sitting next to Morten Mikkelsen, who works on the engine, and I was like, hey, so I know this question's probably impossible, but I want to get like the closest vertice or see how many vertices that I'm colliding with out of the compute shader back into the CPU. I know it's probably impossible. I've been like working on it for a year and I still can't do it. And he's like, oh yeah, you just do this, this, this. So it was really cool to sit next to somebody who actually knew what they were doing, because then I could start doing this where the audio is actually reactive to you. And sure enough, being able to have simulations and being able to sort of visualize those simulations so that you can learn from them turned out to be a really, really compelling experience. I started doing that more, and this is a clip from when we did an event at Sotheby's, and what I did was take a scan of a couch, which you can see over there, and make it so that there was that couch in the real world, so you could go over and you could touch the actual couch, and you could sit down in the actual couch. But in VR, the couch looked like that. So it was really cool because you'd see people going up and playing with the couch and like bending over and touching the couch and looking like total idiots. But in their own mind, they're like, oh my God, this couch is so, so, so cool. But you can see sort of all of this is just exploring like, how do you create a reality that somebody can investigate? This is the last of my pieces for the Unity Artist in Residency, and this is all using sounds from freesound.org. It's scraped and compiled by Kyle McDonald, and then he ran a t-SNE machine learning algorithm on it that groups the sounds. So I'm just going to play this one for a bit because it's really fun to listen to. But basically, every single one of these dots is a different sound from freesound.org. Uh-oh, I need to go back and play this. We're going to look at another version of this. But basically, that was the first thing I did with t-SNE. And it's hard because that one is a bit more difficult to explain as art. But for me, it just is like a literal interpretation of what we've been talking about, where sort of using machine learning, you create this possibility space, this reality, and then using simulation and using real-time reactivity, you're able to make it so it is a reality that you can explore, and it's a reality that you can begin to understand something a bit more about. What exactly you do with that reality is a totally different question. So this was sort of a different exploration where what I did is had a miniature version, and you could sort of choose the sort of location you wanted to go in that possibility space. It brought it to you, it was all around you, and then if you clicked on one of the sounds, it started dropping a ball from that position. And then every time that ball hit the ground or touched anything, it went back to that position. So it doesn't necessarily make good music, but it definitely makes something. And yeah, so basically large version and then small version. We'll skip ahead to where some things are playing. It's a new hit single called Balls Are Dropping and They Make Weird Noises. What exactly you could do to make this a practical way to create music, obviously, I don't have the answers for and don't really know what the answers would be, but it definitely is really fun as a way to sort of give you another tool by which you can understand a reality. So this is the last project that I wanted to show you guys. I'm going to be releasing all of these on Steam so you can try them out. You can hit me up on Twitter to ask more about them or get free keys. I think they'll probably all be free anyway. But now I want to take the time and open it up for questions. If you guys have any questions about what I've talked about, if you have any questions about what I haven't talked about, if you have any questions at all, yeah, please ask them now. And we have a mic, but I can also repeat the question too. I feel like there's not that many people.
Knowing you, you would.
Oh, super awesome talk, brother. Oh, that was outstanding in every way. You actually want to go off menu, right? There's this, lately on Twitter, man, you've been posting with ARKit, just getting the tracking. If you guys don't know, ARKit gives you like these little white balls of where it finds tracking. You've been making these kind of like little biological beings that kind of track them, and you could really see the playfulness. Like with Unity, it's a game engine, right? So you're making these fun things. The final product is a fun thing. But with you, man, for so long, I've been seeing you have the fun in making it. Like you really bring that out more than anybody, man. So and then you also have this color scale. Like I noticed you have so many decisions on like the visual
Yeah,
style of
yeah,
it.
yeah,
Can
totally.
you talk about a little bit about like what you choose when you start making like an asset? What do you look at like to how do you color it? Like
Yeah,
how do you start? How does your process start then?
totally. So let's start with the color one. Um, a lot of what I think about your role as an artist, if you're doing simulation, is more about doing data visualization. It's more about like doing data visualization of the reality that you're simulating so that people can understand more about the reality itself than it is about necessarily making it look realistic. So for example, like I really, really, really like normal maps. A, because then I don't have to think about lighting and I'm lazy and it means that I can spend more time in vertex shaders. But B, because it sort of is taking this data, which is like the XYZ, which is information about the surface of the object that you're looking at, and it converts that. It does this like matrix transform from numbers to a sense. So it basically takes those and correlates it to our cones in our eyes. And so it means that sort of like at like a lizard brain level, we get to more viscerally understand the shape of that object. So in general, like most of what I'm doing when I'm doing colors, especially rainbow colors, is like doing like a hue lookup, but like linking the hue lookup to like a velocity. So even though you might not understand like, oh, that is the velocity that's changing the color, there's something that feels like natural or like intimate about it. And what's interesting to me too is that actually is why I really liked adding the hairs on this object, is because originally it was just this bouncing goo ball, but then the act of being able to have the hairs on it actually were another thing that told you more about the movement of the surface. So it's sort of this like change data visualization of the reality you're experiencing. And I remember the first time that I had the hairs on that and I could really be like, oh my goodness, like that is actually really revealing more about the surface. That to me is when I know that like I'm on the right track. As far as the actual like going about making the mechanics, so like the one that you're talking about on Twitter, which we should probably just pull up. Come on, media. You were talking about like this one. Wait, let's look at this one. So basically, for this, the mechanic of what this is sort of trying to figure out a way to use the data that ARKit gives you in order to create a compelling experience. So sort of everything I've seen with ARKit, and the stuff that still gets the most likes and of the stuff that I do is literally just like the floating shoe. It's like a floating object in space, but it's like with a video in the background and everybody freaks out. But to me, that's like super not compelling. What's compelling is like the crazy data that people give us. And the problem is that that data is usually really messy. So figuring out a way to make that data itself compelling, for me, usually does not mean that you're making something practical or even something that you're going to get points on. It's usually something that's more about play. And so that sort of is a lot of what I think about. And I worked at Leap Motion for a while. And for me, every time I made something, it was never about using quantized gestures. It was how can I visualize the data from my hand so that it can be more reactive, so that I can actually play with it and understand that reality in a more visceral way. Yeah, does that answer?
I mean, I think there's something really magical about rotating cues smoothly, and you absolutely tapped into it. I mean, it really is incredibly satisfying to see.
Oh, thank you.
I think all humans kind of see that movement between hues and understand that
Well,
as like a natural.
and for me, like a lot of it is like, there's this one time where I made this creature, and every single spring on the creature's spine was affected by the FFT of an audio. So it was like slowly like pulsing, but in this very like nuanced way. And I showed it to someone, and afterwards they were like, oh my God, this would be so sick if it was audio reactive. And I was like, oh my God, like it's literally built into the fabric of its being that it's audio reactive. But at the same time, like that's one of the best compliments that I think I've received, where it is like, oh, I assume that you felt sort of like what was happening there, but sort of it wasn't happening at a sort of like semantic level, it was happening at an aesthetic level. And that to me is actually like one of the biggest problems that we're seeing in VR right now and AR, is that it's all about semantics. It's about sort of like what the things are in the world and not what the things are made of. So something like the Rick and Morty simulator or Job Simulator, like obviously they're amazing and a lot of fun, but it's about sort of what the objects are. It's like I am taking a toaster and I am putting a stapler inside of that toaster, and the entertainment comes from what the objects are, not like what the objects feel like or what it's like to be present or how they react to you. It's about sort of like a very high level intellectual relationship between you and the objects, rather than like the physical, visceral interaction with the objects, which to me is what's so exciting about VR. It isn't that I can look everywhere. It's that like I get to have hands, like I get to be a human, and I get to like get sweaty, and there get to be like physical aesthetics. Like I get to make it so that like when somebody gets down on the ground and like looks upwards, they're in a totally different physical, emotional space. And that to me is what's exciting. It isn't about the fact that like I have an HMD. Do you have any other questions? Yeah.
Hi, great talk. Loved it.
Thank you.
Can you talk a little bit more about the sound field with the free sound?
Oh yeah, totally.
Samples. How, just a little more specifically about how that was put together and the taxonomy behind the layout,
Yeah.
the three-dimensional layout of the sound field.
Yeah.
Something like that. Thank you.
So what we're going to look at first is a two-dimensional version that Kyle McDonald worked on called Infinite Drum Machine. And this is super, super fun to play with, and you know you can do it even on your phone. But basically, for this one, they actually bought a specific sample set and ran the algorithm on that. But it is a similar thing where you have a bunch of samples. They're all loaded in. And then the t-SNE algorithm, which I honestly am not the best at understanding, basically creates, it's an algorithm for transforming really, really high dimensional data sets to lower dimensional data sets.
Is that pre-computed?
Yes.
Or is it done each time you run the app?
No, all pre-computed before. So that like takes a really long time. And it's hard because like the dream in real time is that like you could be running that algorithm, and as the objects are congealing, you can be exploring how the algorithm is actually like bringing into existence all this stuff. And it's one of the reasons that we don't understand sort of the states that it goes through, or it's difficult for us to understand the states that it goes through, is because the states that it's going through isn't happening at real time. So I actually talked with Kyle about maybe like doing the same process, but saving out thumbprints of that at a bunch of different times. So then you'd have like, you know, like 300 different versions of the same algorithm all run. And then at the very end, you would basically tween between them so you could sort of see it come into being.
Is it pre-computed in Unity or just totally?
No, totally outside Unity, yeah. So this is, we'll watch this because this gives a super good explanation of it.
Kyle. Hi, Manny. Hi, I'm Yotam. This is something we made called the Infinite Drum Machine. It's basically an experiment to see how machine learning might organize everyday sounds. So anyone who's ever had to work with a lot of sound can see why this is hard. For example, we can all hear that this is similar to this, but totally different from this. But it's hard to articulate exactly why, because sounds are complicated. But this is the kind of thing that machine learning is really good at. So we ran a little test. We played thousands of sounds for the computer. We didn't give it descriptions or tags or any hints on how people usually organize sound. We wanted instead to see if it could listen to them and automatically learn its own way to organize them.
This experiment uses a technique called t-SNE. First, the computer creates a fingerprint from each sample, which is like an image or a set of numbers that represents that particular sound. Then t-SNE compares all the fingerprints and places similar sounds closer together. One way to think about t-SNE is that it's taking these fingerprints from high-dimensional space, which means a space with more than 3 dimensions, and reducing them, in this case, to 2 dimensions so that we can visualize it.
And our test basically worked. This is the T-SNE that we got. We put it on the web so anyone can play with it. You get these neighborhoods of similar sounds that you can explore by dragging around. And make beats with them using this drum machine. We're hoping people find it fun, whether you're more into the machine learning side or more into making music. You can play with it and get the...
Yeah. And so sort of like one thing that's really exciting about the VR version to me is that I also basically there's a bunch of different methods for compressing it down, and so in that one I sort of have a button that changes it, and so from one method to another method, and so you'll see near the beginning you can see it change from one layout to another layout, and it's cool to sort of be able to run your hand through those different layouts and begin to understand a bit more about how they actually work. Another good analogy for me is so that's a different layout. Another good analogy for me is this one that I worked on a while ago called the Tesseract MRI. Let's see if it shows up. Yeah. So basically, this was you taking a three-dimensional slice of a four-dimensional object. This was one that I did for Leap using 3JS. We can see that one of those is 1D slices of 2D, and then 2D slices of 3D. And then sort of what I was wondering is like, okay, now that I'm thinking about that, what does it make sense to have 3D slices of 4D? So that's pretending that the fourth dimension is scale, but in the next one you'll actually see, so this part right here is actually a three-dimensional slice of a four-dimensional object. And you still can't imagine what the four-dimensional object is, but just by sort of getting to quickly explore what that object looks like when you take slices of it, you notice like different, like I know that if I pass a three-dimensional plane through a four-dimensional cube, a hypercube, it's gonna be just a cube if I pass it through flat, whatever flat means in 4 dimensions. So for me, a lot of it is like creating a method to more quickly, it's almost like creating a method to more quickly make mistakes. Anything that like makes a higher iteration time means that you can more quickly understand an object. So especially for the T-SNE thing, like a lot of what I wanted to do was make it for T-SNE because that's really interesting data to me, but more importantly, write something that then can take in any comma-separated value file, bring it into a compute shader, and make it so that you can select the closest one and it's giving information for you. So that one I'm definitely planning on open sourcing too, and would really, like I'm really excited to try it with other data sources. Yeah, does that answer some of it? Yeah. Okay, so that one's pretty, no, it still is using standard Unity object. What I did for this one is, so basically Kyle, when he sent it to me, it's one 3-hour-long file of 44,000 like quarter-second clips. So then I took that and actually broke it into 10 parts to make the import easier, and so that I didn't have to use LFS and GitHub. So basically broke it into 10 parts. When you touch something, so basically what I do is and I've done this with a few other different things too, but I basically create like 15 audio sources, and then every time I play a new sound, I just like add the clip to the next one, so you're sort of cycling through them so you aren't using the same audio source. And then basically it IDs into which sample it's looking at, and then further IDs into what chunk to play, and then plays it. And so then it just is like, it's kind of making like a bunch of audio sources, and you're looping through those audio sources. So technically, if you played enough of them quickly enough, you would have the original ones clipping, but for the most part, especially for quarter-second clips, it works really, really well. Yeah. Yeah.
Hi Hi. Yeah, thanks for the presentation.
Thank you.
Yeah, so a question about VR and maybe a tension that I'm curious how you think about. This tension between, so the fact that, as you said, for you VR is a great medium because you get, kind of a level of fidelity in what you want to explore that's like, the highest you can have of any medium because you can touch things, there is sound, all of that. But at the same time, in the beginning, when you talked about the memory chip and kind of computing, one thing you said is that what's amazing is that it gives you like really super scalable distribution, and a lot of people can experience what you create. And so I'm wondering kind of how as an artist yourself you work with that tension of like, obviously VR is not super well distributed yet, but in terms of expressiveness and fidelity, it's really high. And I know you've done some web work before that obviously has higher distribution. So I'm just wondering at your level, how do you think about that tension? And are you, deciding to do exclusively VR because it's mostly about the fidelity of the work at this point? So just kind of
I mean,
question, but
it's definitely like a really hard one and one that I haven't answered because like Enough, which was like the last big web piece that I did, has like 3 million views. And then Blarp, which is like by far my most popular VR app, has like 40,000. So like going from like trying something out on 3 million people and seeing how they like it to trying something out on 40,000 people and seeing how they like it, and also like a very specific subset of the population is really difficult for me to think is okay. So the short answer to that is like, I don't know, I definitely still struggle with it. That's one of the reasons why ARKit is super exciting to me, because it's obviously a lot more people who have the capability to see it. I do think that what I usually say is more or less that like, I see VR right now as a way to prototype. So like when I work for Leap Motion, like most people weren't seeing the work that I was doing, but because of my ability to sort of like engage with that new technology, I was sort of like learning things that then taught me to make things that felt more physical, even if I wasn't using the Leap. So like the fact that I've been doing so much VR work and thinking about like how interactions in 3D work, it to me is really helpful for creating with ARKit. Even though I might not be using it to do 3D interaction, just the fact that you're considering more deeply computation in all these different forms, to me is helpful. So I definitely would not say that somebody right now should only be doing VR if they're trying to communicate to as many people as possible. But I do think that like in the long run, it's really teaching me about like how humans and like our human body forms interact with computers in a really interesting way, and hopefully being able to bring that to other spaces is what I want to be able to do. So it definitely is cool because every time I do a web project now, like it's obviously informed by all the VR work that I'm doing. Every time I do an ARKit project, like sort of they aren't individual objects. You can learn so much from all of them. And sort of I found one thing that I found really interesting is that once I started doing VR, I got so much more interested in like architecture. I started taking like jewelry making classes. Like it sort of like pointed me in directions that I wasn't necessarily expecting it to point me. So I think that maybe like the most important part is like learn what you can from the technology you're engaging with, but don't fetishize the technology because it still is about communication. Yeah.
Really short one on that note.
Yeah.
Speaking of this and Unity and AR and VR, beautiful. So on the same note, with Unity, the whole thing with Unity is you could basically distribute cross-platform with the same product for AR and VR. Do you find yourself doing that more with Unity, or have you made web stuff with Unity? Like, talk about that.
I mean, I definitely. For me, like if I'm going to do stuff on the web, I'm going to use 3JS, or I'm going to use something that sort of allows people to view the source in the web, because that to me is the most exciting part of the web, is that you get to go in and you get to look at the source, and it sort of is, you aren't sharing the veneer, you aren't sharing the executable, you're sharing the entire object, and that's really, really exciting to me. So sort of like the web makes a lot of sense to be doing 3JS with. As far as phones go, and as far as like like that has been such a godsend to me with Unity, and I didn't realize like how excited I would be to work with Unity specifically because of compute shaders. So sort of what Unity does so well to me is it gives you a lot of pathways that you can dig into in your own direction. So sort of like other engines might be sort of like separating it more. So they're saying like you're either an artist or you're a programmer, and Unity is like, yo, you can try all these different things. And for me, I'm like, wait, can I try this? And it's like, yeah, go ahead. And I'm like, what about this? And it's like, you can try it. It might break your phone. But that to me is what's really exciting about it. So it sort of is, yeah, like it isn't even necessarily being able to distribute across all platforms. It's being able to delve into whichever platform I want to explore. And a lot of that's because I don't think that what works for VR is going to necessarily make sense for AR, or what works for desktop is going to make sense for phone, or like I think that like considering deeply each platform you are creating for is super important if you want to make like a super powerful experience for that platform. Yeah. I think this is probably our last one.
Hey, Isaac. Thanks for giving the talk. I really appreciate it.
Yeah.
First of all, it's really cool that you showed off all your work and explained it. Second, the next team says hi.
Awesome.
And third, so you're exploring a lot of work with ARKit, and you're really trying to push the bounds of what you can do in the data that you extrapolate from it. But other than the feature points that are currently underused by a lot of people, other than those, what do you think is a super underestimated portion of ARKit or AR in general that you feel might hold a lot of power or potential that maybe you have started like titillating with and exploring?
Yeah. I mean, it isn't really specific to AR, but I obviously really like having the video feed. Getting to use that in different ways to sort of make the world be more like the world is pretty exciting. But I do think that like in general, like with ARKit, like one of the funnest things I've done is like you tap, it creates a circle, you drag, it creates a line, you release, there's another circle. So there's a circle here, and a line here. And to me, just the fact that you can use this as like a 6DoF hand controller is super, super exciting to me. And I think that that's sort of what I hope to be seeing a lot more of. I mean, it's still pretty hard. Like I was trying to make one where you take something and you fling it, but like tracking maybe isn't that good yet. But just the fact that like you can be, getting people to be more physical. I think that anytime you can get somebody to move their body in the process of engaging with technology, it's really, really exciting. So one of the coolest things that I've seen recently was called Ubiquity. And they made this thing that is down, it's for phones, so it doesn't really work. But they made this thing, and it's down in Jack London and Oakland. And basically, everybody goes, and they did like a nature spotting thing. And so everybody went out, and we're all looking for these things together. So it was sort of like Pokemon Go, geolocated. But it was so sick to just see a bunch of people out enjoying like really, really beautiful weather because of their technology. Not like in spite of the technology, but because of it. So I think that sort of things that get people to engage with our reality in a different way is like, we've seen with Pokemon Go, is like, I've met human beings who I would not have met before, and like some of them are still my friends because of that game. And that is like, what else could you ask for?
Thank you.
Okay, cool. Thank you guys so much for coming, and if you have any other questions, I'll be around.